This is problem number 4 on the section 5X quiz. It says find the future value of an ordinary annuity. So we know we're going to use the future value of an ordinary annuity formula. If payments are made in the amount R, this R is given here, and the interest is compounded as a given, so there's your given interest rate, and it's compounded quarterly, and it's done for 15 years. So they gave us a value of R. They're telling us, capital R, they're telling us that little r is 0.046. It's compounded quarterly, so m is 4. And we're doing it for 15 years, so t is 15. Now, of course, you have to know your future value of an ordinary annuity formula, and it happens to be S equals R, which is the periodic payment, times this quantity, which is 1 plus little I to the little n minus 1 in the numerator of a fraction, divided by little I, which is the denominator of the fraction. That is your formula. Now, of course, you have to know what each thing is. S is the future value of that annuity. Capital R is the periodic payment. Little r is the annual interest rate. M is the number of compounding periods per year. And of course, you're going to have to use, well, outside, I guess I should also say what T is. T is the number of years of the annuity, the term of the annuity. Now, we're also going to have to calculate little I and little n, and of course, we know that by now. Let's see. I can give myself a little more room here. Little I is R over M, and we know that R is 0.046, so we get 0.046 divided by M, which in this case is 4. And when you divide that out, I won't even actually show that on the calculator because it's fairly simple. You end up with 0.0115. Okay, and little n is m times t, which in this case would be 4 times 15. So 4 times 15 is equal to 60. So I know everything I need to do to make my calculation. They're giving us R and they're asking us for the future value, so we want to solve for S. So I would now say that S is equal to 11,000 times the fraction 1 plus, I calculated little r to be, little I, excuse me, to be 0.0115 raised to the little n power, which I calculated to be 60, minus 1, all in the numerator, over little I, which is 0.0115. Now it becomes an arithmetic problem. You can calculate that entire quantity that represents the numerator, or it represents the entire fraction, without removing it from the calculator. But what I will do, just so you can check for mistakes if you make one, I'm going to show intermediate steps on paper, even though you could just leave the numbers in the calculator and not really write down intermediate steps. So I want to first take 1.0115 and raise it to the 60th power. So if I take my calculator and I put in 1.0115, hit the power button, which is the X to the Y. The power is 60, and hit equal. That 1.9858811026 is that base raised to the 60th power. Like I said, you can just leave that number in the calculator and not write it down as an intermediate step. But because I want you to have as much information on paper here as possible, if you're checking for errors you might make, I'm going to actually write down this intermediate step. You probably don't want to when you're actually solving this problem. And then minus 1 all over 0.0115. Okay, and continuing, let's give myself a little more room. This is a long problem. I've got S is equal to 11,000 times. Now I'm going to take 1.985881026, subtract 1. So I'll just do minus 1 because that number is already in the calculator, and hit equal. And then I take that result, which is 0.98, on, and divide it by 0.0115. So now I take that quantity and hit divided by 0.0115 and hit equal. So that amount that represents the value of that fraction is 85.72878,488. And again, I'm going to write down these intermediate steps so it's easier for you to go back and check if you have some sort of error and you're trying to find it. But if you're solving this problem, you can just keep the number in the calculator if you like and not show these intermediate steps. And so when I multiply that number by 11,000, and notice it's already in the calculator, the 85 something or other, so I don't have to put that back in again. I just times it by 11, 3 zeros, equal. And that tells me now how much money that annuity would be worth. In other words, the future value of that annuity would be $943,016, and rounding to the nearest cent, 63 cents. It actually asked another question. It asked what part of that total amount is based on contributions versus how much is interest. That's fairly simple to do because the contributions is how much this person actually put into the account themselves. And that's fairly easy to think about if you understand what a periodic payment is. Periodic payment is the amount you put in in this case, each quarter. So this person, if you want to figure total contributions, this person put $11,000 into that account 4 times a year, that's quarterly, for 15 years. In other words, 4 times 5 is 60, and 60 is just going to be the small n. So it's really the periodic contribution times small n, but small n is just m times t. So you end up with 11,000 times 4 times 15, and again, that's such a simple calculation. I won't bother to pull the calculator out to do that, but what you end up with is $660,000, and that's the amount that this person actually contributed directly to that annuity themselves. And the final question was the total interest. And that's again easy because the total interest is simply the difference between the future value, which is the $943,016.63, and the amount of the contributions, which are $660,000. And if you subtract those two quantities, you'll find out that the total interest is $283,016.63. So the future value of that annuity is based on two things: how much the person contributed themselves and how much interest was earned over the life of the annuity. If you add those two quantities together, you will get the future value.